And what we're talking about today is it's 4-2b. That's the second part of 4-2. We're talking intro to functions. Today specifically about functional notation. Like functional what? We actually looked at this last year, and maybe you'll see it and be like, oh, I kind of remember that. Maybe not, but hopefully we'll get it down by the end of today. Okay, do you guys remember there's 4 ways to show a relation? What were the 4 ways to show a relation? The first way is by a not a problem or table, but a rule. We didn't look at this very much, did we? We didn't look at rules too often. But the first way is a rule. Then the second way is by a table. The third way was by the maps, okay, circle mappings. And then the last way was through graphs. Okay.
But isn't a rule basically a problem?
It could be considered a problem, but so could graphs or tables.
But it's like that. It's like a formula.
Yeah, it could be a formula. Okay, so here's an example of a rule. And my question is it a function? Does anyone remember, and you can look at your notes, what is a function? It's a
special type of relation.
Good. It's a special type of relation where, and then there's a little more to that. What makes it special? Every has exactly, yep.
Every x value has exactly 1 half.
Good. Every domain value has exactly 1 range value, or every x has exactly 1 y. Okay, so what I'm going to do is, just as a class real quick, we're going to come up with 4 ordered pairs, and we're going to see if we can determine if this is a function. So can somebody give me an x value? Just give me any x value. Don't make it too tough on us, Jack. 1. Okay, if x equals 1, what does y equal? 4. How do you know that? Well, what's 4 times 1? 4. So we got that. Okay, someone give me another x value. Yes, ma'am. 2. Big numbers here. All right, 4 times 2? 8. So what does y equal?
8.
Okay. So if x equals 2, y equals 8. Somebody give me a negative number. Callie?
Negative 7.
-7. If x equals -7, what does y equal?
Negative 28.
-28. And someone give me a negative fraction. And please make it a nice fraction. There are nice fractions in this problem, and there are not so nice fractions. Let's see if you can figure which one. Mandy?
Negative 1/2.
Negative 1/2. What do you guys think? Nice or not nice?
Not nice.
Okay, this is how you determine niceness of fractions. Go ahead and figure that out, and I'll tell you why it's nice or not. Hello? Yes. Actually, he's in the other side. Oh, sorry, Shirley. We switched classes, so he's in Mr. Hubbard's room. Sorry about that. Bye. Okay. How do you solve this, or how do you figure this out? Was it nice or not? It is nice. The reason it's nice is because what can you do with the numerator and denominator? Cancel them out. That makes it nice to do the math. All right. So I get negative 2. So if x equals negative 1/2, y equals negative 2. Okay, looking at these ordered pairs, does that give me a function or not?
Yes.
Yes, it's a function. But how many ordered pairs would fit in there? Infinite. So you're telling me that no matter what x value I get, I'm only going to get 1 y value? Yep, and that means it is a function. So if it's a function, we can write it in functional notation. So you don't have to rewrite that. I did that for myself. Okay, functional notation would be this. For example, f of x equals 4x. Does anyone remember that? Yeah. Those like that f and then parenthesis x. Okay, maybe not. It's okay. It's been a year.
Does f mean function?
The f itself doesn't mean function, but it does stand for function, and you'll see what I mean. Okay, these two equations are the same. What did I replace y with? F of x. Everyone say that? F of x. But I could have easily replaced it with g of x, or You could technically do y of x. Z of x, yeah. You can do
A of x.
Yes, a of x. Okay, yeah.
We never did F. Oh. Yes, we do.
That's okay. We'll let that go. Okay, but you may be asking yourself like, okay, I get you can use any letter, but why would I even want to do that? Like, what's the point? Why? I'd rather see it like this anyway. When I use function, I'll get your question in just a moment. When I use functional notation, I'm saying that these two values have a special relationship. Okay, and I'll show you what that means in just a moment. Yes, ma'am.
Why are you using X when there's a Y?
Great.
And there's an X on the other side.
Yeah, why instead of y did I use f of x, right? Because x and y are related in a special way. And actually, you were going to say it, they're an ordered pair. Like they go together in a special way. So, for example, what was one of those ordered pairs that we got? 2, 8? Okay, that was one of them, right? So this is what I would do. Is 2 8 an ordered pair in this functional notation? So I would say, is f of 2 equal to 4 times 2? So you're like, what? Well, what's 4 times 2? 8. What does f of 2 stand for again? Y. So what does x equal? 2. What does y equal? 8. It shows that relationship a little bit better. Yeah, sorry. What does f of 2, what could that stand for? Y. And what is y? What is x?
How do you know?
So we're saying these two are related in a special way. They're not just like random. Guys, there are random numbers out there. I'll give you a random problem. But what I'm saying here is that x relates to y in a special way. Okay.
How do you know if they don't equal each other?
How do you know if you don't equal each other? If you worked it out wrong.
No, since.
If it's not a function, you can't do anything with that. So you assume it's a function if we said it was a function. But yeah, bless you. Okay, another way of working this out, guys, is to work problems out. Or another reason we work this out is because we get problems like this. Now, look at it. Don't get too overwhelmed. Let me read it to you, and then let's see how we work it out. This is read, f of x equals 5x plus 7. So you guys see this function? How would someone read this? Can anyone read that one for me? Let's read it.
G of x equals x to the second minus 12.
Okay, so how many of you could read it if I asked you just read me the problem? Okay. And then they're asking you something like this. Find f of negative 4 plus g of 3? Is that what they're asking me for? Okay. Here's what I'm going to do. Instead of x, what should I substitute in this equation? I should substitute. Guys, why wouldn't I put negative 4 in this equation? They're asking me for the f of negative 4, not the g of negative 4. So yeah, you can do this. You have two equations, and I say solve for one of them. You're like, okay, which one? Solve for it. I don't know. Just solve for it. This is what I mean. I could have easily done this, and maybe you like this better. Isn't that what I could have done? Okay, solve for y. And what am I asking for? Okay, a solution. But what's a natural question if I gave you these two equations and I said solve for y? What's your natural question?
Which one?
Which one? Are you talking about this one or that one? Oh, the first one. Give me what x is. What am I asking for? If I just said, give me what x is. What's your question that you should naturally think of? Is it this one or that one? I don't know. What's f of x? Which one am I thinking of? Yeah, I'm thinking of this one right here. What's g of x? Which one am I thinking of? This one. All right. So you can distinguish, and there are more applications, but that's for now. Okay, so how do I work this out? I want to find out what f of negative 4 is. So which one am I going to use? F of x. So watch this. Instead of x, what should I put? Okay. Looking at this problem right here, I can't simplify this anymore. This is f of negative 4, that's all. But can I make this simpler? Can I make this simpler?
Yes.
Yeah. What's 5 times negative 4? And what's negative 20 plus 7? Okay, ready? If x equals negative 4, what does y equal? What do you know about these two numbers? They have a special relationship. What's the special relationship? It's an ordered pair, good, and it's related to this. What can we call this? F of x, an equation, or going back to the very beginning, a rule that follows a rule. These guys are together because of the rule. They're not random. Negative 4, negative 13. Where'd you get those from? From the rule. Okay.
So how would you write the answer?
I'm not done with the answer yet. This is the first part. Okay, the second part, does anyone know how to figure out what g of 3 would be, maybe? How do you do that, g of 3? Josie.
We use the g of x.
Okay, I'm going to use this equation, and what do I do to...
You put 3 where the x is.
Okay, so g of 3 equals 3 squared minus 12. Okay. Is there anything I can do to simplify that? No. Can I simplify this?
Yes.
What's 3 squared? 9. 9 minus 12? How do 3 and negative 3 relate? By the rule, which is a special relation, or you can even think relationship. Really, you can think relationship. Okay, great. We got this. These two are linked up. These two are linked up. What do you think I should do with those two numbers? Oh, what's negative 13 plus negative 3? Ta-da! Another reason why we use function notation is because we can combine functions together and their values. So not only are they special, but we can actually add them together and get a more special number. Yes, ma'am.
Are we going to have any problems where we have to make an ordered pair out of them?
Yes, you could technically, yeah.
Ordered pair be negative 4 and then negative 13.
Yep, negative 4, negative 13, or 3, negative 3. Good.
Can you have 2 sets of ordered pairs in one parenthesis? Like negative 2, negative 8, like...
And then another one, right? No. It's... Okay, how about this? Sophie, you brought something up. You normally have 2 numbers in an ordered pair, or you can have an ordered triple, which has how many numbers? 3. And what is that talking about? So normally we talk about a chordate plane. That's 2-dimension. Guess what an ordered triple brings into the 3D. So do we deal with 3D a lot? Yeah, if you understand 2D, then when it comes to 3D, it won't be that much harder because now you're just adding another, you're doing like X, Y, and Z. And guess what we're going to do later on this year? Deal with X, Y, and Z. Oh, we'll deal with that. Or A, B, and C, because that happens. Okay, I think this is problem. I want to see if you guys can do this. This might be our last one. Okay, this is on page 90. Actually, you know what? I gave them a different problem first because I don't want to overwhelm you. Go to... I don't want to scare you guys. Go to page 99, and I want you guys to try number 4. Do you guys see where it says down there, try these? See, try these on the bottom. Do number 4. You're like, what do I do on number 4? Do what we just did on this last example we had up on the board. Yes, ma'am? Sorry? Did you read the instructions? Like, read the bold type? Read those to me, Chelsea. F of in the instructions.
X equals 3x plus 4, comma, g of x equals x squared minus 4x plus 1, and h of x equals x,
Square root of x?
Yes.
Mm-hmm. That's right, that's hard. Okay, so we have 3 functions, right? F of x, g of x, and h of x. What are you doing on number 4? You're trying to find what is f of negative 2 plus g of 5. So does anyone remember what to do?
But I thought the variable was
the variable is in the parentheses right here. So what does x equal? -2. And which one of these?
Oh.
So what you're going to do is you're going to take f of -2 equals 3 times -2 plus 4. You're going to work that out. Does that make sense?
No.
Sorry. So they gave you this, right? So what does x equal? It's whatever's in the parentheses. So it's -2. So you go to the f of x, and instead of x, what should you put? -2. So you just work that out. Okay. Simplify that one. Who could do the g of x?
It would be g and then 5.
5g of 5 equals?
5 squared.
Good. 5 squared plus?
4 times 5 plus 4.
Good. There you go. And then work that out. Minus 4x? Okay. Sorry. I think I wrote it wrong. Yeah. So you write it the way it's there, and thank you for catching that, Josh. Because that would have been a heartbreaker for some of us, especially me. So figure it out, see what you get. Bella, on this second one, they gave you g of 5? So when you're like, what's x? It's always what's in the parentheses. So that's 5. All right, who got f of -2? Who figured that out? What is f of -2, Jack? -2. How many of you got -2? Okay, good. Who got g of 5? Who got g of 5? Cole? 6. Okay? What do you know about -2 and -2?
They're the same.
Okay, they're the same, but they are related in a... Okay, in a special way according to a rule. Okay, what do you know about 5 and 6? They are related in a special way according to a rule. Now, what do you think I do with that -2 and that positive 6? Add them. So what do I get?
-4.
Yeah, positive 4. Yeah, did we have any h of something? So we didn't even use it. So did we have to use the h of x? No, because they didn't ask us for that. Will they ask us for the h of x? Oh, they will. I think you guys are ready. Do number 6. I want to see what you guys do on number 6.
I got 5 squared is 25.
Yeah, yep.
Minus 20 was 4. Right?
Oh, but you have to do left to right. You have to do 25 minus 20, then plus 1. Because remember, order of operations says you got to do adding or subtracting left to right, whatever comes first. Yeah, that's a good question.
What did you say?
Number 6.
So do we apply it to that problem?
Yes, so that in bold type, the bold type. Can you find out what f of 4 is? What do you do in that f of x function? Substitute 4 for x? Okay, so let me walk you. You get this, you get that. What do you do with those two numbers? Add them, and then what do you do? Multiply that number by 2. Yep. So it's almost like an order of operations problem with functions. And you're like, how can you do that? Like that. So Emily, what is the f of x function? Look at the instructions for number 6. So it says if f of x is equal to
3x plus 4.
So what did I replace x with? 4. That's all I had to do. Okay, figure that out. And then, Sophie, what was g of x?
G of x is 8. So it would equal,
Is it?
it would be 8 squared minus 4 times 8 plus 1.
Oh, I think a minus 4. Okay, who has f of 4? Josh? Okay, 16 okay with you guys? Who got g of 8? Cole? Okay, did you get 64 minus 32 plus 1?
Yes.
What's 64 minus 32? 32 plus 1? 33. So thankfully that works. What do you do with that 16 and 33? Add them together. Great. I get 49. But what do I do with that 49? Multiply by that 2 and I get 98. Positive 98. Are these scary? Okay, I heard a lot of no's and a couple yeses. You think this was scary? Number 7. Yes, you're welcome. If you can do this problem, you are allowed to leave.
That's
Well, we gave it's not that hard actually.
It was
You guys did really well, by the way. Goodbye, sir.